This video will provide us with a comprehensive understanding of how Ethereum can interact with other blockchains. Today, we will explore the concept of blockchain interoperability and how it enables communication and data exchange between different blockchain networks. We also understand the significance of interoperability and examine the various protocols and technologies that enable cross-chain communication. We delve into the concept of atomic swap and explore the role of blockchain bridges in enabling the transfer of assets and data. Then we look at the emerging interoperability platforms such as Polkadot and Cosmos. We develop cross-chain dApps and use Polkadot for interoperability. We also discuss challenges and limitations of blockchain interoperability. Blockchain interoperability refers to the ability of different blockchain networks to communicate, interact, and exchange data and assets seamlessly. It is beneficial to us as interoperability enables different blockchains to share data without requiring an intermediary. It helps in efficient asset transfer as it allows assets to be transferred across different blockchain networks without the need for traditional exchanges. Also, it gives us better security as interoperable blockchains can share security protocols and benefits, potentially reducing the risk of attacks. It also reduces our cost by enabling direct transactions between different blockchains. Blockchain interoperability is like connecting different public transportation systems, allowing passengers to transfer smoothly between buses, trains, and subways. The importance of interoperability is like the benefits of having international airports, enabling travelers to reach any part of the world without unnecessary delays. Interoperability is crucial for the blockchain ecosystem as it enhances scalability, improves efficiency, and provides a greater user experience. It enhances scalability as interoperability allows different blockchain networks to work together, expanding the overall capacity and reach of the blockchain ecosystem. It also improves efficiency by enabling seamless communication and data exchange between blockchains. Cross-chain communication protocols are protocols that enable communication between different blockchains such as inter-blockchain communication (IBC) and cross-chain interoperability protocol (CCIP). These protocols are like international telecommunication protocols that allow phone calls between different countries. Inter-blockchain community is a protocol that enables communication and transfer of assets between different blockchain networks. CCIP is a protocol that facilitates the exchange of data and assets across multiple blockchain networks. Atomic swaps are a method for exchanging cryptocurrencies across different blockchains without the need for a trusted third party. They allow two parties to directly exchange one cryptocurrency for another in a secure and trustless manner. Atomic swaps are like direct bartering between two parties without intermediaries. It's a way for people to exchange one digital asset for another without having to go through a centralized exchange or other third party service. In the contract, we first define the swap structure. It contains info about each swap, including the initiator, the hash of the secret, the participant, and the amount. We then have a mapping to store swaps indexed by the hash of the secret. The function initiateSwap initiates a new swap. This function requires that no swap already exists for the provided hash and records the swap details. Then the complete swap function completes the swap. This contract allows two parties to securely exchange cryptocurrency without a trusted third party. The initiator of the swap creates a new swap with a hash of a secret value, and the participant can complete the swap by providing the correct secret. The hash of the secret is a cryptographic hash that acts as a commitment to a secret value known only to the initiator of the swap. Once the swap is completed, the funds are transferred to the participant. Blockchain bridges are solutions to enable transfer of assets and data between different blockchain networks. Some features of the bridges are they help in asset transfer. It makes the transfer of NFTs, non-fungible tokens, and cryptocurrencies very easy. Data exchange. It facilitates the transfer of data such as transaction details and contract information. It also helps us in decentralized finance integration. It opens new possibilities in this field since it allows transfer of funds between two blockchains. Blockchain bridges are like physical bridges connecting two cities, allowing people and goods to move between them. We will introduce interoperability platforms like Polkadot, Cosmos, and Chainlink, which provide the infrastructure for cross-chain communication. Interoperability platforms are like hubs that connect various transportation systems, facilitating smooth transitions. Polkadot is a blockchain protocol that enables the creation of scalable, interoperable blockchains called parachains. Cosmos is an ecosystem of interconnected blockchain that can communicate with each other through the IBC protocol. Chainlink is a decentralized Oracle network that provides secure and reliable data feeds, enabling cross-chain communication and interoperability. Developing decentralized applications that operate across multiple blockchains require the use of cross-chain communication protocols and platforms. This process is akin to building a multimodal transport system that integrates buses, trains, and bicycles into a seamless network. Cross-chain dApps leverage protocols like atomic swaps and blockchain bridges to enable the exchange of data and assets between different blockchain networks. This allows developers to create applications that can tap into unique capabilities and resources of multiple blockchains, unlocking new use cases and enhancing the overall functionality of the dApp. By utilizing cross-chain communication, developers can build deep apps that are not limited to a single blockchain ecosystem, but can instead draw upon the strengths and features of various distributed ledger technologies. This approach promotes greater interoperability, scalability, and flexibility in the development of decentralized applications. Here is an example of how to implement cross-chain functionality in a decentralized application. First, we import the API promise and WS provider from the at polkadot/API to connect to the Polkadot network and Web3 to connect to the Ethereum network. We create a WS provider instance to connect to the Polkadot API and then create an API promise instance. We create a Web3 instance by connecting to an Ethereum node, in this case Infura. Then we define an asynchronous function cross-chain transfer that takes parameters from to and amount to perform a cross-chain transfer of assets between the two blockchains. Here we have the example of the code which was explained in the previous slide. Using Polkadot for interoperability is like using a central hub to connect various regional transport systems, ensuring smooth and efficient transit. Polkadot is a blockchain protocol that enables interoperability between different blockchains, allowing them to exchange data and assets seamlessly. The key features of Polkadot that enable this interoperability are parachains and relay chains. Parachains are individual blockchains that are connected to the Polkadot relay chain, which acts as the central hub. Each parachain can have its own unique features, consensus mechanisms, and token economies, but they can all communicate with each other through the relay chain. This allows for the creation of a diverse ecosystem of blockchain that can work together to solve complex problems. The relay chain is responsible for coordinating the communication between the parachains, ensuring that transactions are validated and that data is securely transferred. This allows for the creation of cross-chain applications and the exchange of assets between different blockchains without the need for centralized intermediaries. By using Polkadot, developers can build decentralized applications that can interact with multiple blockchains, opening up new possibilities for cross-chain collaboration and innovation. This can be particularly useful for applications that require data or assets from multiple sources, such as decentralized finance platforms or supply chain management systems. Achieving blockchain interoperability faces several challenges, including technical, regulatory, and security issues. Technical challenges are integrating different blockchain protocols, data formats, and consensus mechanisms as they can be complex and require significant engineering effort. Two different blockchains obviously work on different kind of modes. Then we have the regulatory hurdles. There are varying legal and compliance requirements across jurisdiction, creating obstacles for seamless cross-chain transactions and data sharing. Then we have the security concerns. Ensuring the security and integrity of cross-chain interactions is critical to prevent attacks and maintain user trust. Despite these challenges, the future of blockchain interoperability looks promising. Emerging solutions like cross-chain communication protocols, decentralized bridges, and interoperability platform aim to address these issues and enable greater connectivity between blockchain networks. As the technology matures, we can expect to see increased adoption and real-world applications that leverage the power of interoperable blockchains. So we saw that blockchain interoperability allows different blockchains to communicate and interact. We also saw about the protocols IBC and CCIP, which enable cross-chain communication, whereas atomic swaps and blockchain bridges facilitate asset transfers. Interoperability platforms like Polkadot and Cosmos provide the necessary infrastructure. While blockchain interoperability offers significant benefits, there are still many technical, regulatory, and security challenges that need to be addressed. Here are some questions you can do.